Have you ever found yourself wanting to know the effect several factors pose on a single variable? For example, if you were researching the effectiveness of two studying techniques on a Calculus 2 final exam, and for some reason, the effectiveness of each technique differ between students of different genders and their choice of major, then you have a three-factor interaction between study techniques, genders, and majors of students in a Calculus 2 finals, and you can use what is called the three-factor ANOVA. A three-factor ANOVA helps with identifying if there is an interaction effect between three independent variables and a continuous dependent variable. In the example above, the three independent variables were the two studying techniques, genders, and majors, while the dependent continuous variable was performance on a Calculus 2 final exam. With a three-factor ANOVA, you need to check for 6 assumptions. The first one being, your dependent variable needs to be measured at a continuous level. Second one, the three independent variables needs to consist of two or more categorical independent groups. Third, you need to have independence of observation on your data. Fourth, no significant outliers. Fifth, dependent variables should be almost normally distributed. Sixth, there needs to be a homogeneity of variance for each combination of groups of the three factors. In computer engineering, we often deal with circuits and electronic devices. Let's say we're looking at gaming benchmarks or running 3 different video games: Overwatch, League of Losers, and Robo League. The gaming benchmarks are affected by GPUs, NVIDIA or AMD, and which CPU, Intel or Ryzen, you paired it with. We would like to know if there's a three-way interaction between the 3 video games, 2 GPU brands, and the 2 CPU brands in determining gaming benchmarks. For this example, we'll be testing a number of random computer setups. Both brands of GPUs are evenly split and further subdivided into either CPU brand. Then each subgroup is tested for one of the 3 video games. Eventually, using three-factor ANOVA, we would like to know if there's a statistical significant three-way interaction between video games, GPUs, and CPUs, or not by testing where there are simple 2 interactions, let's say between GPU and CPU, differ between the levels of video games. With this quick definition and example, I hope you have gained understanding of using three-factor ANOVA in statistical analysis and its fun applications to an engineering situation.